OpenAI released this new audio generation, which uses the same model as the real-time audio API, real-time speech API, but using chat.completion. So you can input text and audio, and you can receive text and audio. So I've gone through it and created some sample scripts, which we are going to go through from simple to more advanced. And the code files for this will be available at my Patreon for free. So if you actually, I'll edit into the comment right now, Twitter, right, and then we'll start right away. Okay, so this makes calling the API with audio much simpler because before we had to take in user audio, transcribe it with Whisper, and then wait for the response from the chat completions, then use some kind of um, text to speech, right? Another API, but this one actually just kind of brings up. It is some drawbacks because it actually uses the same price point as the real-time speech API, so it's quite expensive, but it really simplifies it, and there is latency. So this is for use cases that don't require real-time interactions. So let's test it out with the first file, basic chat. Like I said, these will be available at my Patreon. Let's do, let's run this real quick. So we are going to first test it with just text input and audio feedback. And I will quickly go over the code and we'll move step by step. So if I just say hi,
Hello, how can I help you today?
so as you can see, we get an audio response in return, and it takes about 3 seconds. Let's say, what is 2 plus 2?
2 plus 2 equals 4.
Okay, so another benefit is that these voices are directly from GPT-4 or audio preview, so they are more natural. Like I said, this is useful for use cases where you don't require real-time voice. Plus, this is way simpler to implement, and it supports function calling. We're not going to get into that. So this first basic implementation actually does not have a message history. So let's begin. You just make sure to update your OpenAI library, right? So you can access this new modalities parameter. So we are using load.n, but actually I don't have a .env file. It's automatically detected from my system environment variables, my API keys, but you can use a .env file as well. We create a get audio response function, which is going to call the GPT-4o audio preview with our common chat.completions endpoint modalities being specified as text and audio. So you can actually specify which modalities you're looking to work with. You can also specify the voice and the format, and everything else remains the same. Here we are keeping track of time when we receive the response. Message.audio.data will contain the audio data, and the response.choices.message.audio.transcript will contain the transcript. And now we return the base 64 encoded audio data transcript and just the elapsed time to make sure to see how long this actually took. That's about it. So and then we have a play audio function. We're just using Pygame. We're just going to play it. That's it. So in our main loop, we just taken a user input. Then we call the API, and then we just play it. That's it. And we do this in a loop. So this is how it works. Uh, that's how this one works, but it doesn't have a message history, right? Next, that's what we're going to talk about next in the second file. What did we talk about? It's not going to remember, but it's always responding with audio. And the latency is pretty
I apologize, but
yeah,
I'm unable to recall.
unable to, because it doesn't have a message history. So our next one actually is going to fix that. Everything's going to remain the same, except here when we make the call. Where are we doing that? Pending, we're going to append, conversation.append. So we're going to create a conversation list. This is exactly the same as basic chat. But when we receive a user input, we are going to append it to the conversation history. And then when we receive back a message, we are supposed to append it as well somewhere here. Yeah, that's right. Uh, when we receive the assistant response, we add it as role assistant, content as transcript, plus we pass in the audio ID. Okay, you don't have to pass in a whole audio like you would have to do if you're inputting it with audio. Yeah, that's so it's very convenient. As you can see here, if you go to their documentation, it says that for multi-turn conversations, this is what the assistant will return along with the transcription which we are using. It returns an ID. So you can just simply pass back this ID and it'll know what we talked about. Okay, that's what I mean. That's how this works anyway. So if we test this, if for example, what is 2 plus 2? Oh, what is 2? Okay, that's fine. I guess it's philosophical. Now
It
it's going
seems
to
like your question is incomplete.
good.
Could you please provide more context or
That's fine.
clarify what you would like to know about 2?
Yeah, as you can see now, the audio file plays in full. We're going to actually introduce interruptions next. And now we're going to also take a look at how we can input it with audio, user audio. But let's continue this. So we did ask something. Let's say, what is 2 plus 2? And next we'll ask,
2
wait,
plus 2
remember?
equals 4.
4, okay. What did we talk about?
We discussed the answer to the math
Yeah.
question 2.
So this is how we do it, okay? It's the exact same thing as basic chat, except as soon as we get user input, we append it to the conversation history. And when we receive the audio and the transcript, we add it to the conversation history as the role assistant, plus the content is the transcription, plus the audio ID. So it's very simple. So again, iterating that the value of this is when you don't require real-time interactions. This is very simple to implement. It supports function calling or tool calling. And it provides the exact same natural voices as the real-time voice API because it's the same model. Downside is that it costs the same as the real-time voice, so it's going to be expensive. But it's more controllable and it's easy to use. So that's the I just want to do a caveat. Now we can actually, like I said, these files will be available at my Patreon for free members, so you can grab them if you want to experiment. Link should be in the comment if you're on Twitter, and I'll put it up on YouTube after this. But if you actually in my website or in my YouTube video search for real time, you will find some videos with actually using Opus back in the day, which real-time voice chat. I actually created a pretty ingenious system where we are actually streaming the responses and actually sentence by sentence converting the streaming responses into audio with user interruptions to try to achieve as close to real time as possible. So I have 3 or 4 of these videos, so you may want to check those out. I'll try to make another one to update that. The reason for that would be is because real-time API is so expensive and it's difficult to implement. Middle, and since this has high latency, as we've seen, even simple responses take 3-4 seconds. A middle way can be achieved, actually, I believe, which I'll explore later. Okay, so now having said this, let's move on to the third uh, file, which is to be able to interrupt the audio so we can go back to taking user input. Uh, this will still take user input as text, but let's see how it works. For example, ask tell me a story, tell me a short story. So this is going to take a minute to generate plus a while to play, but we'll be able to interrupt it to go taking user input because we are also printing the transcription, so we don't have to wait for the entire audio to finish playing. We can just read through it.
Once upon a time, in a peaceful village,
So press space to interrupt, and we have interrupted.
You interested in another story?
Sorry, I pressed enter. That's why it immediately triggered. But space interrupts it, going back to taking user input. But the transcript of our previous conversation is printed. We can read through it. As you can see, this took 20 seconds. Yeah, and sometimes this API hangs. I'm sure they'll improve the responsiveness of it. But yeah, so again, to say this just makes things way more convenient, but there is latency and it's expensive. Just remember. So how we did this is pretty much using keyboard library. The requirements are also listed. We used keyboard library to detect. We will use keyboard library to detect the interruption. So we have a function named get audio response, which is going to return an audio response, deal with all that. Play audio is going to play the audio as we have done before, but we check to make sure that if Pygame Mixer is currently busy, which means it's playing something, we continually check if the user has pressed space using the keyboard library. If that is so, then we stop the Pygame Mixer. We clear the keyboard buffer so in the hopes that it won't transfer to the next input, but I'm not sure if this actually works. We return true that we have interrupted. We also print that playback is interrupted. Otherwise, we just return false. In the main loop, as you can see, we play the audio, check for interrupted. I don't think this is necessary. We're not using it because it's a Boolean. So this play audio is going to get interrupted anyway if the user has pressed space, and then we are breaking. Oh, we're returning, which will effectively end this function. And right after that, whether the audio has completely finished playing. Oh yeah, Mario. Sorry, I just saw your message. No, I actually tested. There is no streaming, unfortunately. Yeah, you can simulate streaming, like I mentioned in. I made videos on that to try to mimic or simulate real time. You can take a look at those. Maybe search for voice chat. Yeah, yeah, yeah. This was super fast two-way Opus voice chat. I was able to achieve pretty fast speeds even with Opus. This is back in the day. Back in the day, me being just a few months ago. But there is no streaming, so you just have to wait for the whole response. Okay, so play audio function will either play the audio in full or the audio play will get interrupted. In either case, we are going to insert the transcript and audio, and after this, the loop will go back to while loop to take in user input. So that's how it works. Again, if you test it, this is the third file, interruptible chat, hi, and then as soon as the audio starts playing, I will
Hello.
space to go back. As you can see, the space is still transferring to the terminal because it has nothing to do with keyboard, I believe. Anyway, that's a small. The fourth one is actually to be able to use both text and audio, user audio, to talk to the model. Let's see how this works. When you start it, you either to start typing or to press space to record, and you hold space key while recording. I guess it should we should clarify that anyway, but essentially I can just say hi and it immediately takes in the user
Hello. How
text.
can I assist you
We
today?
can press space to interrupt, and then we can press and hold space to record. What is 2 plus 2?
2 plus 2 equals 4.
Yeah. Okay. Please tell me a very short story. I'll try to interrupt it to make sure it works. Yeah. See, there's latency, but
Once
still.
upon a
And press space to interrupt. Plus, you get to see the transcript. So this let's see how this works. So this may require FFmpeg installed. There's a super detailed Hostinger article on how to install FFmpeg for all uh, operating systems. It's in the requirements. You can also search Google for it. I'm pretty sure this requires FFmpeg. I already have it installed. We are also using sound device. It's in requirements. So let's see how this works. The get audio response is the same. Play audio is the same, right? With interruptions. Record audio here. When you record audio, you gotta hold the space bar, release to stop. It sets some, variables, and then while the keyboard is press space, it just continually reads the audio stream. And it uses NumPy to concatenate each chunk, and then returns the audio data plus the sample rate. And we save the audio to user input.wave, right? Because once we save it, then we can now use that to input into the model. Because here, we're going to input it into the messages list. Let's see how we are doing that. So we're saving the audio, and then we get user input. We say enter text or hold space. We should change this to say hold spacebar to record. And if the keyboard detects a space, then it triggers record audio, which in it has a while loop. So this will continue running this function as long as the space bar is being pressed. And then we record the audio. If there is audio data, we pretty much save it. It also returns the base64 audio. Then we just this returns the object, list object, which we're going to input into the messages list of text type plus the input audio, which is base64 audio in the wave format. Now here we get the user input. This is either get user input is either going to be either text or an audio. We just append it, right? Because the function is returning it in the proper way. Okay. Yeah. Yeah. So if there's audio, it returns it like that. Otherwise, it just returns it as whatever the user input is. As you can see, you can do this. It's pretty cool. You can take in user input directly. Yeah, so that's it. So the rest of the stuff is exactly the same. And so this now allows you to talk to GPT with your voice or text in a very simple way, I guess. Are plants conscious? Excuse me. So this may be a long response.
Plants do not have consciousness in the way animals or humans do. They don't have brains or nervous systems, but do respond to their.
And press space to interrupt. So yeah, this is just useful to get you quick scripts to get you started. Like I said, they're available at my Patreon for free. You just have to become a free member. You don't have to pay anything. And everything else remains the same as far as chat completions is concerned. Meaning you can implement function calling here, whatever else. Everything remains the same. Make sure to update your OpenAI library. And remember, it uses GPT-4o audio preview. It has the exact same pricing as the real-time audio, so it's pretty expensive. Remember that. So, and it is pretty high latency latency. So this is good for the kind of applications if you don't require real-time responses and you want the simplicity of chat.completions. This is a go-to for that. Well, thank you. This was a quick one. I'll end it here now. But if you enjoyed this content, my content, you can find more at my website, echohive.live. I have over 350 actually videos that you can watch for free. And if you decide to become a patron, and then, well, thank you very much because you'll be supporting me doing these videos, informative videos every day, almost every day. Plus, you'll be able to download any of the project files for any of my projects, such as Fast Transcriber. Click download. It'll take you to Patreon where you can download the project files. You'll also have access to my 1000x cursor course. It has it has 323 chapters, over 13 hours of content. You can watch the first chapter for free, and you can preview each of the chapters for up to 2 minutes. And I also, if you wanted to talk to me one on one, and if you need help with your projects or something, I do consulting. I have special tiers on my Patreon for that. Check those out as well. I hope you found this useful, and see you in the next one.